Hello everyone and welcome to today's fantastic video with which you will learn how to program. This may be your first video on learning how to program. So in this video and the next couple of videos that are going to be posted on this channel, you will learn how to program as a whole. Like firstly, we will start from why or what runs on your computer and why or how that does. We first of all start with your computer or CPU or laptop, whatever you may wish call it. So this is the first thing. Uh, Name this as the first thing. So the first thing we will do in this video, the first the first thing about which we will talk in this video is your computer. The second thing that we are gonna talk about is what actually do people who program do. What actually programmers do. So what is their day job? Like how do they earn money? Why even they earn? So what do they actually do to get the money and why are they given money for that thing? Okay, nice. The third thing. Uh, Now in these steps you will know nothing about a single piece of program, and the third thing is like why is what programming language slash path is suitable, and everyone has their own needs, so you may have different answers for this by the end of this video. So this is actual thing that we are going to discuss in this video. So what is on your computer, what do programmers actually do, what programming language is most suitable for you, and then we will start with the first uh, line of program, Python. Python is a language, and you may have like got the answer to this. There are multiple languages that we are going to cover. So a programmer's job is not accomplished by a single language. You should have multiple languages for that. Okay, so let's talk about this in more depth. So first of all, let's just start with the computer. Like now you have your computer over here, so there are plenty of things going on in your computer right now. Like for example, you are watching this video on YouTube. So like take this for example, is your CPU. So you've got multiple things in the CPU running. This is a like rough sketch of them. So this thing here is RAM. Let me give this a name, RAM. And then let me have another shape here. You may have some internal memory as well. Your computer, your CPU may have some internal memory. So this is the internal memory. Wait a second. Internal memory. And we'll talk about the difference between RAM and internal memory in a second. Now the remaining two portions are, this is arithmetic and logic unit, and that's all it is. And there may be a fourth portion like graphics card, but you can have a computer with just these two things. Graphics card. Like this is what or graphics processing unit. This is all it is. Now, one there was a man known as von Neumann, and he was a scientist. He said that you know we the earlier computers or nowadays computers the computers of today as well as the earlier computers that were in existence used his architecture. His architecture was simple, like why can't we have just a single thing? Like he said that there are just three things in order to make a computer. First of all, you need what you need is memory, like this the memory. Second of all, you need a logical unit to process all the arithmetic behind those operations. Like this arithmetic can be a lot more than you might think. That simple addition, subtraction, multiplication, like calculating the number of pixels in and which pixel will be colored as black. Like you see, this region is colored black, this is blue, all this kind of stuff. And the third thing will be input. This is just a rough sketch. So let's give them a name. This is input. This is your uh, this is your RAM or memory, or let this be the logical unit of your CPU, the CPU of the CPU, the where the logic is. And this is RAM or memory. Okay, nice. So actually what happens is you give something your computer input. Why? Uh, why rotate it? Yes. So you give this some input, it processes it in this logical unit, and the logical unit stores that to the memory. And the best part here is that this is an actual computer. We're not even talking about something like a monitor or printer, something that will let the user know that your input has been completed. But you, the the thing is, if you if you are done with something, somebody gave you something, you did it, you stored it in your memory, that's fine. But yeah, if you are free, you can tell. If you don't want to tell, you should not tell the person. Or if you're not said to tell, you won't tell the person that this thing is done. We are just talking about earlier computers. So, like this is how it functions. The input goes into the logical unit. It sends some of the numbers into RAM and memory, and the RAM and memory sends something to the logical unit. This is how our computer actually works. A rough sketch, a rough idea of how it functions. Nice. Now there are plenty of things in our modern computers. Do you even know? Do you even have an idea of it? Like if you have a modern computer which is running an operating system like Mac OS, Linux, something like that, you may know that there are a lot of apps, and those apps can do a lot of things, a lot of things, and it does not mean that sometimes it is impossible to just have this simple thing. That's why we have graphics card, RAM, and nobody knows how many things, but this is the basic structure of all our modern CPUs. Now, what happens in the logical unit is actually what programmers are interested in. The input, the RAM, and everything else are the needs of hardware creators, hardware makers, other people. That's nice. Now, how do we know what's going or what is actually going on the logical unit? Uh, so, logical unit does what it says. It processes. It does the logic. So, what kind of input should we give to the logical unit and how it processes the data? So, the input which numbers take are usually in which computers take are usually in form of binary digits like zeros and ones, a long string. Like for example, zero is corresponds to, if zero corresponds to a zero, then one corresponds to a one. This is binary, and this is the numbers that we write in, okay, the Arabic numbers. So here we have 1 0, that means okay, you got 2. So 1 1 means 3, and so on and so forth. So it's not hard to see that it's got a base of 2. There are just two numbers, 0 and 1, and everything can be created out of them. 0 is called a no, 1 is known as a false. The earlier computers used transistors. Nowadays, they also use transistors. Transistors nowadays are cheap, so transistors can portray these numbers very nicely. How can they? 0 corresponds to a switch off in the transistor, and 1 corresponds to a switch on in the transistor. So if you give a number 0, that means that particular transistor is off. 1, it means it's on. So if you have 4, you will portray it as will portray it here as transistor off, then one and on, another on, and the last one off. If you have 1, you will portray it with one transistor on. This is how you do process. And now logical unit adds and subtracts and multiplies, but we are not operating on that complexity as the world has grown more and more, and the day job of people has got much easier. So now medical students don't dig a hole in the skull of normal patients and tell them, yeah, we brought some leeches, and that's what earlier people did. The early people, they brought leeches to the body of um, people who had wounds and treated them with leeching. Now people don't do that because now science has grown more and more. So that's exactly what is happening today in uh, our computer, our programming, or whatever you may say. So let us go here. So, like, there is a pattern, there is a pyramid, you may say. So this is that binary thing. This is the binary language. Sitting above that is the we are knowing this as in the language because it is, you can portray alphabets with the Unicode pattern in this. We will talk about that later. So and sitting above that is assembly language. Assembly language is what your modern computer understands, like your Windows, your Mac, your Linux, whatever. Now, sitting just above that are lower level languages, and but don't panic yet. You're not gonna deal with lower level languages. These are lower level languages. Just above is middle level language, and just above that, the just above the middle level languages are higher level languages, which we are going to deal with today. So this is the language. These are the languages of today, programming languages of today, known as higher level languages. So this is a middle level language, and this is a higher level language. Level. So what actually happens? This is very interesting how it happens. Now you write code in higher level languages, which transpiles directly sometimes into assembly, and your computer can read assembly. Your computer is now a scholar. He can read assembly language and convert it into binary, so that the transistors in your CPU or your CPU as a whole can understand the code, your code, and run it. So that's why these complex websites are created. Like, now if you visit any other app, question yourself, like, how is that even created? Now there are two types of people. Like, if you visit a monument and you are not a sculptor, you will be amazed. And if you're a sculptor and you visit a monument, you will question, you will be curious, like, how is this even created? So now from now on, let's just start questioning. So this was all a overview of what are what we are going to deal with. So this is a computer, what actually programs do. And now let's talk about what programming language or path is suitable. Now in these high level languages, there are many languages. uh, like, there are hundreds and thousands of them. You can't even name them. And so I will name a few popular of them. Like, the most popular of them are on the earth are like C plus plus, C sharp, Java, Python, and lot more. So the now programming languages can also be differentiated and categorized and classified into a lot of ways. We are not going to deal with this. So the language which I recommend as the perfect for beginners is Python, because Python is very similar to normal English, if else, and the syntax is also not very confusing like Java, C++. So once you are done with Python, you can move on to bigger, harder, ferocious languages like Java, C++, C Sharp, C, any other language you may name. Okay, now let's uh, let's also differentiate. Let's also write some Python code now. So what you will actually do here is download Python from this website. I will have the link. Yeah, I will give you the link in the description. This is the website, python.org/downloads, from which you can download the Python interpreter into Windows. Now, what is Python interpreter? Now, Python interpreter, what it does is, it's just a program which transpiles your high level language of Python code, which you write in a file to uh, directly into assembly or binary language, which your computer can understand. Your computer does not understand Python. Python interpreter will act as a translator. For example, you are French, your friend is Spanish and you are talking, how can you talk to your Spanish friend? So the translator comes in, he knows French as well as Spanish, he can translate. That's what Python interpreter is. That's all. Now you should also download, you should head over to code.visualstudio.com to download Visual Studio Code. Visual Studio Code is a code editor or IDE that you can use for developing Python apps. There are others, for example, just to name a few, there are PyCharm, which and Thonny. Thonny is also pretty fun for beginners. So if you so and the thing is that Thonny comes with already comes with an IDE. So if you are a beginner, you should download Thonny. You may also, and if you are a beginner, just download Thonny. You also don't need to download Python because it already comes with a Python interpreter installed. So this will also be fun, but I suggest you to download Visual Studio Code because it can run not only with Python but other programming languages. So once you've installed, done, you can install it for Windows, Mac, or whatever. You are done. You have set it up. Now let's head over to Visual Studio Code. Now this is my Visual Studio Code. This is how it looks like. There are a ton of extensions that you can install. I've installed a lot of them. You can install your favorite theme. I like Dracula. And here is Python IntelliSense. You can search for it and you can download it in the extensions. Now what it will do is it will help you with your Python code. That's what it does. And also Pylance, we'll talk about that more in this video, in the later upcoming videos also. So let's create a file. So to create a file in Python, you must have with the extension .py. So .py and any other file name like hello or index or main would work. So here I'm going to name main.py. That's what I like. And you can see the Python logo here, classic Python logo with two snakes, one at the bottom and one at the top. So Python or any other programming languages use some fundamental data structures. The first one we are going to encounter is variable. Now what is a variable? Variable is anything which has a value. Like if you have studied in maths in high school in 8th, 9th, 7th, whatever, like x can be you can name your variable whatever. So you can name it, I don't know, home, way, Spider-Man, Tony Stark, I don't know, whatever. So I'm going to name it score, and you can give it a value. So score is equal to 0, you give it a value of 0. So now variables can have values, and values are types of data. There can be a lot of types of data. Like this is an integer or a number. That's all. Like 0.0 is an integer, 0.0, this is a floor number, or this is floating point number. 0.7, these are decimals, floating point numbers in Python. 0, let the score be 0. And there can be other type of data types as well. Let's see them. For example, name is equal to, my name is Ishan Tiwari. This is a string. String is always enclosed in double quotation marks or single quotation marks. You can have it. So this is a number string. Let's set up two more, and there can be lists as well. So birthdays or like list of countries. This is a list. A list is square brackets, and any you can have any type of data in 0 separate, and every type of data can be separated by a comma. Like here I want a list of countries, so I want a list of strings separated with a comma, like China, Bhutan, USA, uh, A, India, a lot of countries. So there can be. Let's start with this. Let's have a number and a string and a list. So these are data types, and beware, you can't do this list of countries. This will be false. This will be like a sin, because variables like this is wrong in the syntax. Now interpreter will try to read what you've written. Scope, okay, is equal to that means assigning a value. Zero name is equal to something. Okay, I missed a list of countries. This is a whole word. It does not know English. So list of countries is equal to China, Bhutan, in USA, India. But he will go down. He will say list. What list? I don't know what is list. Off. I don't know what is off. Countries. And he does not know countries. He or she, whatever. It does not know any of your of your gibberish. So you must talk to him with his language, like list of countries. Now you see, it show me something like this. If I click on this, it shows me this. It is a list of strings, and this is known as a string in Python language, Pythonish language. So list of countries. Now this is fine, but yes, and now you can run it, but this will do nothing. Let's run this, and you see it runs in the terminal. So that brings us to another thing, the terminal. What is the terminal actually? So if you have a Windows laptop or Mac OS if you have a Windows laptop, head over to CMD, which is command line, and that is your terminal. Mac OS, head over to terminal, that is your terminal. And Linux, head over to terminal, that is your terminal. So the terminal allows us to execute simple programs like this. These are known as CLI, command line interfaces. So this is command line. You can type in commands and this will execute. Like if you have Linux or Mac, it will execute commands in Bash. Bash is a language. So CLI language. So I will say echo I am great. This will work. But this may not work in Windows. I'm not sure, because Windows does not use Bash. So to use Bash in Windows, you have to download Git Bash. We'll come to that later. So if you have to give it some output, like hey, I just said you to have this list of countries. Now I want you to print that list of countries. I want you to do that. Save. And now if you print the list of countries and run this, it will just give you an output like this: China, Bhutan, USA, India. So this gives an output to us on the command line as well. We don't use a graphical user interface like app. We have not created our first app yet, but yeah, this is a form of a mini app. You may create your app someday. So list of countries. Now if you have, if you want to get a specific part in this, you can get like this is the zeroth element, this is the first element, this is the second element, this is the third. Like this is a series, you must say. N is equal to 0 gives China, N is equal to 1 Bhutan, N is equal to 2 USA, N is equal to 3 India. So to get that one thing, you have this square brackets again. You type your index like 0 if you want to get China. Let's save that and run that. China, yes, you got it. Now you can have you can do a lot of things in this. So and yes, I forgot another data type. Another data type can be a boolean. So n- is human is a boolean. So boolean is either true or false. So this is true, this is false, false and true, false. You don't need to cover that in uh, quotation marks because that will become a string. See, now this is a string, but false, printing false, this is actual keyword. A keyword is a statement or a word or a phrase in the program that means something to the interpreter. Like false means to the interpreter, false means zero, or false means false, or a transistor down to the interpreter. So is human is false. If you want to print is human false. So and you can set booleans another pretty interesting way. Like you can have these brackets. 9 is equal to 8. Now see here that you may observe that we have is this equals, that means check whether it is equal to 8. So if 9 is equal to 8, he is human. That's pretty rubbish, but let's run this. False. And if 9 is equal to 9, let's see what happens then. So this true. So 9 is equal to 9. So is human is equal to 9 is equal to 9. 9 is equal to 9. Yes, that's true. So is human is true. Print is human is true. That's what we got in term. So you may want to code along like this here, and I recommend you doing that. So today's video is a bit enough. In tomorrow's video we'll discuss about loops and other things, other very interesting things that you may want to